So yeah, I'll talk about basically how bacteria can be used in sustainability, and I would talk a bit about my research, but a lot of it is still unpublished and parts of it under NDA. So I decided to talk about another topic that's closely related to mine that I find very fascinating, and it's based on the idea that the earth is a circular ecosystem, so all the processes that we see happening are circular in nature. So for example, if a tree grows, eventually it'll grow old, fall over, and then it'll be degraded to provide nutrients and materials for new trees to grow. However, people are very good at making things last. As Connor demonstrated, we're excellent at making new materials that have never been seen before on this planet before. So there's no way of disposing of these. And what we've come to realize is that perhaps we can develop ways or use nature in a way to help us deal with this issue. So first, a bit about myself. I have a background in neuroscience, but I became very interested in biotechnology and actually switched my career path completely. And now I study bacterial growth, mainly focusing on lactic acid bacteria used in cheese production. And what I found very interesting about this whole topic of microbiology is, as this doctor from Jurassic Park, Ian Malcolm, put it, life finds a way. So when we look at the most inhospitable parts of our planet, we find that organisms can actually live and grow there. So we have places like acid mine drainage waste or hyperacidic lakes and volcanoes, where you think like nothing could possibly survive here. But when we actually look, we see that there's organisms growing there and they're perfectly happy in these extreme conditions. Um, so this led to the realization that we might be able to use microbial organisms to tackle plastic pollution. And basically, in response to the accumulation of plastics in the biosphere, people became aware that microbes are adapting and evolving to catabolize these man-made plastics to use as energy sources. And this is really important because plastics weren't really used until the 1950s, but we've basically been making millions of tons of them every year. And here you can see an estimation of all the plastics that were ever made so far in millions of metric tons. And unfortunately, while we do try to recycle these materials, the majority of these 8,300 million metric tons are discarded or incinerated. And this is not going to go away anytime soon. In fact, our consumption is predicted to increase every year. So this is something that really needs to be looked at. And one of the ways that people were thinking of dealing with this issue is using microorganisms to try and make this process more circular, as we see in nature. And in 2016, these scientists in Japan actually managed to find the first, find and isolate the first bacteria that grows on polyethylene terephthalate, or PET, as it's easier to say. So this was so exciting because normally one of the properties that you want plastics to have is that they don't biodegrade. So it's actually quite difficult for bacteria to be able to do this. And I'll show you some of the data they generated where they grew these bacteria over here in figure A. You can see, oh, sorry. In figure A, you can see this plastic strip of PET plastic being degraded by these bacteria. And you can see the crater-like substance that they leave behind. And they have some very nice electron microscopy images of these bacteria over here in figures E and F, where they have these fine string-like projections that manage to attach to the plastic, and then they release a variety of enzymes onto the plastic that leaves this crater-like appearance you can see in figure G. And what's amazing is that the entire piece of plastic could be degraded in just 40 days. So here in figure H, you can see the weight of the plastic over time. And this is exciting because with a rapid optimization, we now have a means to upcycle plastic and really reuse these products rather than just try to recycle them. And here you can see some molecular simulations where the enzyme is taking PET and breaking the bond to make something like ethylene glycol over here. And this allows us to really not just recycle PET, but get all these additional benefits out of it, such as getting completely new monomers, such as terephthalic acid and ethylene glycol, that can then be used in different products. So this is a very exciting application of using biology to degrade waste materials. And I think this is something that will become very important for us as a species later on to really start using biology to our advantage. Thank you.